So electrolysis. If you see here, the word itself has two parts. Electro means we are using electricity, and lysis means breaking up. So with the help of electricity, we'll decompose certain things, and that process is called electrolysis. So to know about this process, you have to know some more things. So what are the things we are going to make, going to pass electricity through, that you have to know, isn't it? So for that, uh, a few points you have to know. So first we'll talk about those points only. So for that, let's see this diagram and then we'll talk about it. Okay. So I'll give you a diagram first. I'll just take a container here. In this container, I'm going to take a liquid, this filled with a liquid. Now in this liquid, we are going to pass electricity. So to pass electricity, we have to insert two rods. So these two rods which we are going to insert, they are, I've drawn it here. So this can be metal rod or it can be made up of graphite. So this will help us to pass electricity through this liquid. Now to pass electricity, this has to be connected with wires, isn't it? So we have already studied in physics the meaning of this. What does this mean? You should be knowing. What is the meaning of this? You should be knowing, isn't it? So if I join these things like this way, okay, if I give you like this, then in this case, different things we have taken. What is the this one? You can see here two bracket like things are there. What is this? This is a key. That means a switch. This switch is off. If I give a dot in the middle, then it becomes on. These two lines are cell. Cell, if it is one single piece, and if there are more than one, we call it a battery. Clear? The smaller one is negative and the larger one is positive. Always remember that. If I had given it like this way, one smaller, one bigger like this way, then in this case, what is happening? I have taken three different cells. So in that case, I can call it battery. Clear? And the longer one is again positive and the shorter one is negative. So I have connected a key, a cell. This symbol is for a bulb. The straight lines which are joining here and there, they all are wires, isn't it? And then the two rods are there and the liquid is there. Clear? Now when I take this and then if I just switch it on, the bulb may glow or may not glow. If the bulb glows, then the liquid conducts electricity. If the bulb does not glow, the liquid does not conduct electricity. Clear? So here, whether the liquid conducts electricity or not, to find it out, we are just using a bulb, and the bulb glows, it conducts electricity, the liquid will be called an electrolyte in that case. So suppose we think that the bulb glows, then in that case this liquid, will call it electrolyte. Clear? This electrolyte has to be a liquid only. It cannot be solid. So it has to be liquid. And this liquid, generally what happens is, if suppose I have a solid, I can take it in molten state. You can take it in molten state, or you can also take it in aqueous solution. Aqueous solution means it is dissolved in water. Molten is also called fused. If I say fused state or molten state, both of them, they mean the same. Okay, so solids we are not taking. Even if it is a solid, if the substance is a solid, we'll heat it, it will become a liquid. Okay, that is in fused state, and if we can dissolve it in water, then in that case it will be called uh, aqueous solution. Okay, so basically what we have got here is, I can just write down here. If the bulb glows, then the liquid conducts electricity, isn't it? And the liquid is called electrolyte. That means this liquid can conduct electricity. We'll call them electrolyte. Yeah. But if the bulb does not glow, then what will you call it? If it does not glow, then the liquid does not conduct electricity, isn't it? If the bulb does not glow, then the liquid does not conduct electricity. And is called non-electrolyte. Yeah, so it can be an electrolyte or it can be a non-electrolyte. So when we talk about electrolysis, we are concerned about electrolytes. We do not want non-electrolytes. Clear? We have to look for electrolyte. Clear? So the liquid which I have written there, that is a electrolyte. Now, in this electrolyte, what we have done, we have inserted two rods, isn't it? These two rods, they are there to conduct electricity through the liquid. So these rods, they are called electrodes. The rods are called electrodes. Now, these two rods, one of them will be positive and one of them will be negative. So which one is positive? Left hand side one or the right hand side one? Which one is positive? Left hand side or right hand side? Hari,
Left hand side.
left hand side is positive. You can see here,
Left.
just see the cell. The cell is positive here, isn't it? And negative on the other side. So positive means this end is positive and this end is negative, isn't it? So the positive one, the one which is connected to the positive end, that is called anode. And the one which is connected to the negative end is called cathode. So electrodes can be of two types, anode and cathode. We'll see the details of these things, but they are the ones which are connected to positive end and the negative end. The one which is connected to positive end, anode, and the one which is connected to negative end, is your cathode. Understood? These terms we need it, so that's why we are doing it first. We'll look into each and every term, so one by one. Now, the next thing is to carry out electrolysis, we need this complete apparatus, isn't it? We need the electrolyte, we need the electrode, we need a key, wires, bulb, cell, everything we need, isn't it? So this complete setup of this system, the apparatus, that complete setup of the apparatus is called electrolytic cell. Clear? Electrolytic cell. Okay, in case of water, it is also called voltameter. It's an electrolytic cell or voltameter. Understood? Now, uh, this electrolyte will conduct electricity. Non-electrolyte, they don't conduct, isn't it? We have already clearly written electrolyte and non-electrolyte. So when I say electrolyte, here this liquid is electrolyte, means it will conduct electricity, and when it conducts electricity, this electrolyte will break up into ions. Clear? So this electrolyte, it has to dissociate into ions. When we are taking it in molten state, it has to dissociate into ions, or if I take it in aqueous solution, then also it has to dissociate into ions. Clear? So when it dissociates into ions, it forms a positive ion and a negative ion. It can form two types of ion. The positive ion is called cation, and the negative ion is called anion. So cation, anion, you have to know. Cathode, anode, you have to know they're just oppositely charged. You'll see cathode is negative but cation is positive. Anode is positive but anion is negative. Understood? So these terms you have to know. Now from these terms we'll go into the next part. Now we'll see what are the things which we have to study. These are a general description of the terms. Okay. Now from these terms, uh, let's deal with the process of electrolysis. Clear? So let's take that now. We'll define things one by one, and these definitions are important for you all. So the first thing, let's take the name only. Electrolysis. How will you define it? It's a process, isn't it? Just now I told you what you are doing there. We are passing electricity through different substances. Of course, a liquid which can conduct electricity. That means we are passing electricity through an electrolyte. And when we pass electricity through an electrolyte, then the electrolyte decomposes. Lysis, that word is decomposition, I told you, isn't it? The electrolyte decomposes. And when that decomposes, that decomposition is brought about by current, and therefore it is called electrolysis. It is decomposition in presence of current, isn't it? So to define it, what we are saying is uh, electrolysis, you can write down, is a process of decomposition of an electrolyte. Decomposition of an electrolyte. Remember, as I say electrolyte, it means it conducts electricity. Decomposition of an electrolyte when electricity is passed through it. Now, when you pass electricity, it is not the normal substance in which you are passing. The substance has to be either in molten state or in aqueous solution. Okay, through it, then in its fused state or in aqueous solution. It has to be either in its fused state or it has to be in aqueous solution. Then in that case, what will happen? When it decomposes, then that decomposition, we call it electrolysis. Clear? For example, if I say example, we'll see the detail of the process also, but just for the time being, if I take an example, then what can happen? H2O, that is water, isn't it? This water, if I pass electricity through it, when I pass electricity, this will break up into hydrogen and oxygen. Basically, whatever it is made up of, those components are formed. I could have taken any other thing. Water is a liquid itself, so we don't have to do anything. But if I had taken, suppose, NaCl, then this NaCl, it has to be fused or molten, isn't it? In this, we are passing electricity. What will happen? This will break up into sodium and chlorine, but chlorine is Cl2, so balance it. It will be balanced like this way. You can take any substance. This decomposition will take place if ions are formed. So we'll see the formation of ions also. But if I had taken this PbBr2, lead bromide, this also fused or molten. You are passing electricity. You can also write down current is the same thing. Don't get confused there. If current is written or electricity is written, both of them, they mean the same. So lead and Br2, bromide is formed. Understood? So this is electrolysis. Now from electrolysis, we need electrolyte and electrodes. So let's talk about those things also one by one. Let's take the first thing, that is electrodes we'll talk about, and then we'll go to electrolytes. What are these electrodes? What are these electrodes? They are rods, simply rods, and with these rods we are passing electricity through the electrolyte, isn't it? So electrolyte, uh, we'll talk about it later on, but electrodes, what are they? Electrodes are the two metal or graphite rods, are the two metal or graphite rods used to pass electricity. Used to pass electricity through an electrolyte. Again, the electrolyte in its fused state or in molten solution, not molten, aqueous solution. So again, we are using a two metal rods. It can be graphite rods or it can be metal rods. Clear? So we are using two, isn't it? So these two, what are they called? We have already done that. They are called anode and cathode, isn't it? So we have anode and cathode. If I compare them, what can you say about them? Both of them are electrodes, isn't it? But anode is the one which is connected to the positive terminal of the battery, isn't it? So anode, it is the electrode connected to the positive terminal of a battery. Is your first point. So here what will I write? The same thing. It is the electrode connected to the negative terminal of a battery. Clear? Now, current flows. You have already studied in physics. These charges are due to the presence of electrons. If a substance has lots of electrons, it becomes negative, and if it has less number of electron, it becomes positive, isn't it? So here anode is positive, you are saying, and cathode is negative. That means anode, it has less number of electron, whereas cathode will have lots of electron. So the second point I can write down, it is deficient of electrons, whereas on the other side, what will it be? It has excess of electrons. So since this has excess of electron, it can easily give electron, whereas the other one has less electron, so it can take electron. So the third thing what you can write down, uh, it can easily accept electron. It is positive, it has less number of electrons, so anyone wants to give electron, it will readily take it. And here it can easily donate electron. So who is giving the electrons? Cathode. And who is taking the electrons? Anode. If I say cation, what will happen? Cations are positive. So they'll move towards the negative. That means cations will go towards cathode and anions will go towards anode. So when cation comes towards cathode, it will take a electron and become neutral. That means it gets discharged. Okay. So the fourth point is that one. Number 4, anode. What will come towards anode? Anions are discharged at anode. And here I'll write down cations are discharged at cathode. Is it clear? Apart from this, if I take the flow of electron, electron flows from which end to which end? Current flows from which end to which end? What is the direction of flow of current? Current flows from positive to negative or negative to positive. In physics, you have already done. In which direction will it flow?
So negative to positive.
Negative to positive. Are you sure? Current flows from positive to negative. Current flows from positive to negative. So if I take these two
Yes.
electrodes, what will happen? The current enters into the electrolyte through anode and it leaves the electrolyte through cathode. Clear? So the next point I can write down, number 5. Current enters the electrolyte, isn't it? And at cathode, what will happen? Current leaves the
Leaves.
electrolyte. So what you have done basically here is an ion. An ion is positive. It will take an electron, isn't it? So what will happen? Anions are negatively charged. They donate an electron. So when they donate an electron, the anode will take it. So anions, they donate electron means they're losing electron. And loss of electron means what? Loss of electron means whenever there is loss of electron, what does it mean? You have done again chemical bonding, you did, isn't it? Loss of electron and gain of electron. I told you what does it mean.
So oxidation and reduction.
So loss of electron is what?
Sure, oxidation.
Oxidation, isn't it? So what is happening here? Anions, they lose electron. So in case of anode, what I can say, anions are oxidized here, and here cations, they gain electron. So cations are reduced. So at cathode, reduction is taking place, and at anode, oxidation is taking place. Is it clear? So these are some basic differences between anode and cathode. Whatever is happening at anode, just the opposite will act as will happen at the cathode, isn't it? Then let's go to the next part now. We have done electrodes. Now we go to the next part, that is electrolytes. Just now I told you in the beginning, electrolytes, what are they? They are substances which can conduct electricity in liquid state. Liquid means molten state or fused state, they can conduct electricity. So these substances, they are called electrolytes. If it cannot conduct, it is a non-electrolyte, isn't it? So electrolyte, to define it, what will I say? Electrolyte are substances that conduct electricity in their fused state or in aqueous solution. Remember, I told you the bulb will glow. So the bulb glows, whether it is glowing bright or dim, that does not matter. As it glows, that means it conducts, because liquids may conduct less amount of current, may conduct more amount of current. So we are not talking about less or more. We'll see when we are classifying them. But anything which conducts electricity in its fused state or in aqueous solution, we'll call it electrolyte. Clear? But these electrolytes, they do not conduct in solid state. Clear? So any substance that conducts electricity in the fused state or in aqueous solution, they are electrolytes. Okay, they do not conduct electricity in solid state. Now here, this makes a difference, because if I take a metal can conduct in solid state also, it can conduct in liquid state also. So metals, they are different conductors. They're not electrolytes. Electrolyte means solid state, it won't conduct. But in molten state or in aqueous solution, it will conduct. Clear? An example. I can take is sodium chloride. Clear? Now, if I take a example here, sodium chloride, NaCl, lead bromide, potassium chloride, etc. are electrolytes. That means these things in solid state they don't conduct. If I take the molten state, it will conduct, and if I take the aqueous solution, then also it can conduct. So why does it happen so? Why they can't conduct in solid state, but suddenly in liquid state they can conduct? Why is it so? That question is also asked many times. Clear? So let's take an example. I'm just taking the example of NaCl, but in your case, any other thing can be asked. Your answer, the way of answering will be same. So if I say this NaCl, that means sodium chloride, does not conduct electricity in solid state. Why is it so? What is the reason behind it? In solid state, it does not conduct. But according to the definition, in molten state, it can conduct, and in aqueous solution, it can conduct. So why in solid state it is not conducting? The reason behind it, you have to know it, isn't it? So I'll give you here. If I say NaCl, sodium chloride, that is NaCl, is an ionic compound. An ionic compound you have already studied. It's an ionic compound made up of and is made up of sodium ions and chloride ions. Is made up of sodium ions, chloride ion, and these ions, how are they held? Which are held together by a strong electrostatic force of attraction. So it has ions, but these ions are held together by a strong electrostatic force of attraction. Clear? So basically what happens, you have already studied when we did chemical bonding. NaCl, what will happen? You have a Na plus, but this Na plus will be surrounded by Cl minus from all the sides, and a Cl is surrounded by Na plus from all the sides. So you'll have like this way, isn't it? It has a cluster of ions, a group of ions. Clear? And since it has a group of ions, what will happen? Cluster of ions there, which are forming the solid, isn't it? And there is a strong electrostatic force of attraction, isn't it? So because of that strong electrostatic force of attraction, these ions, they cannot move. In solid state they cannot move. Okay, so what I can write down here is due to this strong attraction, due to this strong attraction, the ions in solid state cannot move. So ions are there. These ions cannot move. That means they cannot carry charges. And if they cannot carry charges, they cannot conduct electricity. So what you can write here, they have a cluster of ions, a strong electrostatic force of attraction, and ions cannot move. So in absence of mobile ions, means movable ions, in absence of mobile ions, uh, NaCl in solid state cannot conduct electricity. So ions cannot move, so it cannot conduct. It's simple as that. Why the ions cannot move? Because of the strong electrostatic force of attraction. There's a very strong electrostatic force of attraction due to which the ions cannot move. Is it clear? So why NaCl does not conduct in solid state, that you know. This is the particular state in which it is present, isn't it? Now, the same NaCl, if you take in fused state, then it can conduct. Or if you take in aqueous solution, then it can conduct. So why is it so? That also we have to know. Have you all finished? This one finished, then we'll go to the next page.
Yes, sir.
Okay, so now the next thing is the same NaCl. Hmm. NaCl can conduct electricity in fused state. So why is this so now? It can conduct electricity in fused state. Why is it so? Now, for this to conduct electricity, the ions they have to move. You know, ions are already present, but they were held together by a strong electrostatic force. Now, we are converting it into a liquid. So, since we are converting it into a liquid, what will happen? We are supplying energy, and that energy is enough to overcome the force of attraction. Clear? And once that is overcome, then the ions they can slide over each other. In liquids, they can slide over each other. So for this, what will I write? Sodium chloride when heated. Sodium chloride when heated melts. Melts means it becomes a liquid, isn't it? and in molten state, it dissociates, producing ions, free ions, which can move. So you have free ions and the ions can move. So what is happening here is NaCl, you had solid, isn't it? What did we do? We heated it. So when you heat it, it will become NaCl, now molten or fused. And in this fused state, what happens? This will break up into Na plus and Cl minus. They are separated now. Previously, they were held together by a strong electrostatic force, but now they are separated, and since they are separated, they can move. Okay, so these free mobile ions are the ones which conducts electricity. So these ions, they are free to move because we have already heated. Heated means you have supplied lots of energy. Because of that energy, they have already overcome the force of attraction, and therefore they can move. And since they can move, they are conducting electricity. So in molten state, it can conduct, but in solid state, it could not, isn't it? There's one more state in which it conducts, isn't it? So that also we'll see. So the next one will be NaCl can conduct electricity in aqueous solution. That means when you are dissolving it in water, it can conduct electricity. Okay, why does it conduct? We have to write down that now. Here what happens? You're dissolving in water. So in water it forms a solution. And in solution also it dissociates. Why it dissociates? Because of water only. Water is a polar solvent. So polar solvent means it has charges. So because of those charges, they can dissociate. One more term is there, but you won't understand that term. Water has a high dielectric constant. So that term generally we avoid it. Clear? Because those things you won't understand here. Okay, so you can just say due to the polar nature of water, it dissociates. So when it dissociates, it will form free positive and negative ions, and they are the ones which can conduct electricity. Clear? So I'll write down. Sodium chloride. When dissolved in water, when dissolved in water, I can write down due to the polar nature uh, and high dielectric constant of water. Due to the polar nature, remember the first thing I have written is polar nature, means water also has charges. Because of that charges, these charges they break up. So sodium chloride when dissolved in water, due to the polar nature and high dielectric constant of water, it dissociates. It dissociates, uh, forming sodium ions, that is again Na plus, and chloride ions, that is Cl minus, which can move freely. So in solution, these things can move, and since it can move, it can conduct electricity. Charges can move, then it can conduct electricity. So here also, what will I say? I'll write like this. NaCl solid, I'll add water. Because of this water, this will become Na plus, but this is in AQ. AQ means aqueous. In aqueous solution, it can be separated. So because of water, it dissociates, and these ions again they are free, and therefore they can conduct electricity. Yeah. So due to the presence of these free ions, it can conduct. So due to the presence of these free ions, it can conduct electricity. So why it conducts in these two states and why it does not conduct in the other state, that also you know. I've taken an example of NaCl, but it could be anything. They could have asked for potassium chloride. The only thing you'll do is NaCl, you'll replace it by KCl. Or they could have asked for lead bromide. So NaCl, you'll replace it by lead bromide. But your answer will be same. Clear? So an electrolyte can conduct in liquid state or in or in aqueous solution, but it cannot conduct in solid state. What is the reason behind it? We have already done. All of you have copied. Everyone has copied this. Then let me know.
Yes, sir. Yes, sir.
Okay. Now look here. We have just seen electrolyte. If it dissociates into ions, then it can conduct electricity. That means it is a must for the electrolyte to dissociate. Yeah. So what I can say here is the electrolyte must dissociate producing oppositely charged ions, isn't it? Those oppositely charged ions are producing cations and anions in order to conduct electricity. So if it can dissociate, it will conduct. If it cannot dissociate, then it will not conduct. Okay, so basically what is formed? Cation and anion. So let's see the difference between this cation and anion also. So one side I'll take cations, another side I'll take anions. Cations and anions, basically many differences you already know. What is it? What will it be if I say cations and anions? First thing, they differ in their charges. Cations and anions, they differ in their charges. What type of charges do they have? Cations are positively charged and anions are negatively charged.
Negative feature.
So we'll write down that first. Number one, cations are positively charged
Positively charged.
and anions are any mistake. First you have to point out. The second thing, if you take this, as I told you, positive means it has less electrons and negative means it has lots of electron. So what you can say, cations, uh, it has deficiency of electrons, whereas in anions, what will I write? It has
Excess.
excess. Okay, now since deficient and excess, if I compare them, then in case of cation, number of protons are more than number of electrons, whereas in the other case, number of protons are less than number of electrons. Then cations are formed by loss of electron, and anions are formed by gain of electrons. If anything gains electron, it will form an anion. Then the fifth one, cations, they move towards cathode. Cations will move towards cathode, and anions, they move towards uh, anode. Okay, and then if you take again, since anions have lots of electron, they can give electron, and cations have less electron, they can take electron, isn't it? So what will happen? uh, Cation, it uh, accepts electron and get neutralized, isn't it? That means they are reduced. And anions, they give electron, means loss of electron, and then they are neutralized. Okay, so one more point I can write down here. The cations are, we wrote there also in anode and cathode, the last point, what did we write? What did we write? The same thing we'll write here. Cations are reduced at cathode, and this one, anions are oxidized at anode.
Anode.
Gain electron and lose electron. So that is given in terms of oxidation and reduction. You will have done the difference between atom and ion, isn't it? Before, when we did chemical bonding, difference between atoms and ions you have already done. So you'll go through that also. Then, since we are talking about electrolyte, again, this electrolyte will classify them. Mm, electrolytes can be classified into three types. What are they now? We can have three different types of electrolytes. What are they? The three of them. Any idea? You can have the first one.
Strong electrolytes, weak electrolytes, non-electrolytes.
Strong electrolyte. And the last one is so three things are there. Now what or how do we classify them? It is something similar as we did strong acid, strong bases we have already done, isn't it? So same way this is also classified. If I take strong electrolytes, what are they? Just like strong acids, they completely dissociate. Yeah, when you add it to water or when you take the molten state, everything will dissociate. If I take 100 molecules, all the 100 molecules will dissociate. Then that will be called a strong electrolyte. Yeah, so a strong electrolyte uh, undergoes almost complete dissociation. Complete dissociation means whatever is there, everything will dissociate. Undergoes almost complete dissociation when dissolved in water or in its fused state. So undergoes almost complete dissociation in its fused state or in aqueous solution. Whereas if I write the same thing in the second one, what will happen? If I take 100 molecules, a part of it will dissociate and the part will not dissociate. So undergoes partial dissociation. In its fused state or in aqueous solution. What about the last one? This is number one only. Will be number one. Here also number one. What will it be? It does not conduct. So what will happen? They do not undergo any dissociation in any state. Whatever be the state, they do not dissociate. So whatever be the state, it will never dissociate. So due to that, what will happen? Look here. In the first case, what is happening? Everything dissociates. Whatever was there, everything dissociates. So when everything dissociates, they produce a high, they produce a high concentration of ions. Whereas in the second case, all are not dissociating, so they produces a low concentration of ions. Whereas the third one, if I take, then what will happen? uh, do not produce ions. So basically what is happening, if I take this, then everything dissociates. So they are consist of ions only. Because if I take 100 molecules, all the 100 molecules will dissociate. So no molecules will be left, only ions will be left. So they consist of ions only. Whereas in this case, they consist of ions as well as molecules. And here it will be consists of molecules only, because they are not dissociating, so they'll have only molecules. Weak one, if I take 100 molecules, a part of it dissociates, maybe 20, 30 dissociates. So the remaining are still molecules. So they have ions also, they have molecules also. Clear? If you take the conduction, how much they can conduct, then I can say conducts large amount of current, because many ions are there, they can conduct large amount of current. Here conducts small amount of current. Whereas the next one, what will I say? Does not conduct. So the last one does not conduct current. Is it clear? Then finally, we can take some examples. So number 5, examples. Uh, I can take NaCl, KCl, all strong acids and bases. All strong acids are strong electrolyte, all strong bases are also strong electrolyte. Then the next one, example, if I take this one, then NH4OH, ammonium hydroxide, CH3COH, acetic acid. In fact, you can say all weak acids and bases. Weak acids and weak bases, they all are weak electrolyte. And the last one, you can name any substance that does not conduct. If I say sugar does not conduct, salt conducts, but sugar does not conduct. Clear? Glucose does not conduct. Pure water, if I take pure water, then that also does not conduct. And then any non-polar liquid, they do not conduct. Like I can say alcohol, ether, benzene, carbon disulfide, all these things, they do not conduct. Kerosene oil, petrol, all these they don't conduct. So they all are non-electrolytes. So organic liquids, you can say. So this is the difference between strong, weak and non-electrolytes. Now here, just a simple thing. If suppose it is asked, how will you identify whether the substance is a strong electrolyte, weak electrolyte or non-electrolyte? Because you cannot see how many ions are produced and all those things, isn't it? How will you identify them? Remember, we can identify easily just from the first thing which I told you. In the beginning only, what did I say? When we were talking about the first part here, I told you this bulb glows, isn't it? The bulb glows. So if the bulb glows bright, if it is bright, that means it is a strong electrolyte. If it is glowing dim, then it is a weak electrolyte. And if it does not glow, that is a non-electrolyte. Clear? So just by seeing the bulb, how can you identify? I'll just write down here. The bulb glows bright. In the second case, the bulb glows but it is dim. And the last one, the bulb does not glow. So if these things you can see, you can easily say which is a strong electrolyte and which is a weak electrolyte. Understood? So today's class will end up here only. Today's class we are ending up here. Okay, any problem, anyone?
No, sir.
No, sir.